Professor Wagner, Principles of Macroeconomics, Chapter 5, Elasticity. The outline covers the following topics: price elasticity of demand and supply, polar cases of elasticity and constant elasticity, and then elasticity pricing and elasticity in areas other than price. Economic elasticity, using Netflix as an example. Netflix is a streaming service, and it includes the United States and goes around the world. And the question is how did people react in 2011 when it announced a major packaging change, including an increase in price? Okay, basically, I think everybody understands that Netflix really didn't take much of a hit. So there was a certain lack of elasticity, but we'll get into that a little bit more later. A bit of glossary, perhaps, for a test. And so these are terms: elasticity, and that's basically talking about the responsiveness of one variable with respect to changes in another. Price elasticity is defined as a change in quantity, demand, or supplied corresponding with a change in price. And then elasticity of demand is basically the percentage change of the quantity demanded divided by the percentage. And then price elasticity of supply is the percentage of change supplied divided by the percentage of change in price. So these are probably things I would definitely earmark to know for the test. And so with that, they give you some parameters. One, how to calculate it and how to interpret it. So basically, you have three different cases. So if the change in quantity divided by the change in price is greater than 1, we would consider that particular situation elastic. A change in quantity is equal to, and change in price is equal to 1, that would be called unitary. And then if it's less than 1, it's inelastic. It's definitely something to know. Of course, there's another way to calculate the elasticity of a curve. And so they have a midpoint method for elasticity. There's a couple formulas here for you. Basically, the latter quantity minus the original quantity with both quantities added together divided by 2 times 100. That would be a change of quantity. A similar thing with respect to price, just different variables. Same idea. In this example, what they're doing, first step is take percentage of change in quantity, and so you have 6.9 after you work it through the formula. They do the same thing for the price, which is a negative 15.4. And so with that, they take the absolute value of 6.9% divided by 15.4, and that's 0.45. This would be considered highly inelastic. In this particular example, the elasticity of supply, they do the change in quantity, the change in price, and the quantity, the change in quantity, or delta Q divided by delta P is equal to 3.35. And so that would also be deemed highly elastic. This graph you won't see very often in the real world. However, it's considered infinite elasticity or perfect elasticity. This works for either demand or supply. And so basically the quantity demanded or the quantity supplied really doesn't have any response to price change at all. And so the curve is horizontal. Whereas zero elasticity or perfect inelasticity, a percentage change no matter how, change in price, no matter how large, results in zero change in quantity. So this would mean the good, or whatever we're measuring, is simply immobile in terms of elasticity. Or constant unitary elasticity when applied to demand, and that's a very key concept. So this is only for demand curves. It'll be curved. And how do they make it unitary? It's basically when the percentage, the rise over the run, divided by each other equals 1. So 33 divided by 33 here, 1, 25 by 25, 1, 16.7 by 16.7. So this would be considered a unitary demand curve. And this is in contrast to a unitary elasticity for a supply curve. It's a straight line, and it reaches up from the origin. So it always starts here and goes up with some slope. In between each point, the percentage of increase in quantity demanded is the same as the increase in price. Once again, 33 divided by 33 is 1, 25 by 25, 1, and 16.7 by 16.7 percentage-wise, also 1. Elasticity and pricing. Businesses are always looking for ways to produce things at a lower cost, and as one pathway to create a higher margin or higher earning profits. In some cases, the price of a key input over which the firm has no control may rise or fall. And can the business pass cost or cost savings on to customers? So these are quandaries that businesses think about on a constant basis. So criteria for passing along savings to cost savings to consumers, technological improvements. So cost savings cause supply to shift out to the right from S0 to S1. So this is a case where S0 goes to S1. And if the demand is inelastic, the result will be technological improvement will substantially lower prices. And that's, indicated by the movement down the demand curve from E0 to E1, this price versus this price. If the demand is elastic, as in B, the result will be only slightly higher prices. So once again, we have S0 shifting to S1. However, the delta between E0 and E1 is very slow. Okay, this is an illustration of passing along higher costs to consumers. Okay, they're going to use rising taxes. This is something that happens quite frequently. So in this case, you have a higher tax, let's say on cigarette companies, for example, will lead to a supply shift from the left. So if we were to take a look at S0, it moves over to S1 to the left. And so what changes? The equilibrium that we had along the demand curve was here. However, it shifts over here. The new equilibrium is up here. So up the demand curve, it's basically only decreased ever so slightly. The quantity demanded is very small here with respect to the large difference in prices, the original prices versus the price after you put more tax on cigarettes. Okay, higher costs with the elastic demand. Basically, it's kind of the same as before. The supply curve shifts to the left. And so the original equilibrium, when this quantity is produced, moves over here up just a little bit. And so the delta in price in this particular case is very small. And it has a lot to do with the slope of the demand curve. It's very sharp. You'll see a much bigger delta between these two, whereas if it's a flatter, more horizontal curve, it will actually, the delta will be less between P0 and P1. Elasticity and tax incidence. Okay, it's a manner in which the tax burden is divided between buyers and sellers. If demand is more inelastic than supply, then consumers will bear it. If it's the other way around, supply is more inelastic, sellers will bear most of the burden. Okay, this illustration speaks to elasticity and tax incidence, and basically it's a graphical explanation. So if demand is more elastic than supply, then the tax incidence on consumers is lower than tax incidence on producers. So this would be tax incidence on producers, whereas above the line, PE here, this would be the tax incidence. That small thin purple area would be what consumers get to see. If it's more elastic, then the consumer, then the consumers will bear the brunt. So the producers have this area underneath here, whereas the consumer is all this shaded area up here. So it shows the consumer bearing more the brunt of taxation in this case. And then there's always the discussion over long run versus short run impacts. And so elasticities are very often lower in the short run than in the long run. On the demand side of the market, it can be difficult to change the quantity demanded in the short run, but easier in the long run. On the supply side of the market, it's typically easier to expand production in the long term of several years rather than the short run of a few months. A good example of what's going on now today, the N95 mask needed for healthcare professionals and first responders. We don't have enough, and so we are working, diligently to increase the supply because the demand's quite high. In most markets, the short run prices bounce up and down more than quantities. In the long run, the quantities will move more than the prices. And okay, this is a illustration of the responsiveness of demand to price changes in crude oil. So graph A shows inelastic demand for oil in the short run. So this is your demand curve here. So the change in equilibrium, from about $12 again to 25, really not much change in the quantity demanded down here. However, more elastic demand over the long run. So this short run, not much happens. However, it's more elastic in the long term. So you want to know more elastic over the long term. And why is that so? Okay, well, you see that the difference between quantity and demand, the delta between these two places here, is greater than the delta between this price and that price. And a shifted equilibrium from here to here. So longer run, number of barrels, demanded, there won't be a whole lot of price change if there's a shrinkage of demand in this particular illustration. Elasticity in other areas rather than price. Okay, you have the income elasticity of demand. So change in the quantity demanded would be divided by the change in income. Probably we'll see something like that on the test. Most of the time, the income elasticity of demand is positive. That is, a rise in income will cause an increase in the quantity demanded. That's true for most things. Cross price elasticity of demand is the influence of one good, the change in the quantity of one good, influencing the change of price in another good. So what are some examples of complement and substitute goods? Complementary goods would be like hot dogs and hot dog buns. Substitute goods would be like hamburger buns can substitute for the hot dog buns. And so where a change in price of one good may cause a change in the demand of the other. So, if you have a change in price of, let's say, hot dog buns going through the roof, people would likely go ahead and substitute it with a hamburger bun, for instance. Whereas the hot dog and the hot dog bun are complements. In this slide, we have elasticity in labor supply, and labor demand. And you'll notice the formulas are similar. Change in quantity and demand, so that's a delta, and delta in the wages, the delta in change of quantity and demanded, and the delta divided by the delta in wage. So these are once again ratios used as a measurement for the elasticity, which all the rules for elasticity still apply. If it's less than 1, it's very it's very very inelastic. If it's more than 1, it's very elastic, and of course unitary is equal to 1. Elasticity in financial capital markets isn't really a whole lot different. And once again, it's the percentage of change, the delta in financial savings versus the change in interest rate. And then on the flip side, the borrowing elasticity is change in quantity of financial borrowing divided by the change in the interest rate. So we're going back to Netflix in this slide. The 60% increase, in 2011, how did that look afterwards? Before the increase, you had 24.6 million subscribers, and then after the price increase, less than a million had canceled it. And if you move ahead to June 2013, there were in fact 36 million streaming subscribers. An average quarter growth of about 1.6 million. This was less than the 2 million per quarter increases that had been the previous norm before the price change. So why was the estimate of customers leaving so far off? What missteps did Netflix management make? Well, it was a misjudgment of the elasticity of demand, because there are close substitutes such as Amazon Prime and Hulu, and then also misjudgment of customers' preferences and taste. They were still customers that still preferred a physical DVD over streaming video at that point in time. End of chapter 5.